Good morning all. You can see this is the solar cell, fabricated solar cell, and this one we made ourselves. And here you can see the solar cell is a monocrystalline solar cell, and there is a two points, the white points. This is called the buzzwords. That means the contact we will take from one from here, another one is from the bottom side. So this is basically the solar cell which we have seen, and after that we have to make the module, and from the module we will get the solar panel, which we can see in different places, right? So now what is our main objective today? To measure, how we can measure the different solar parameters using the solar simulator, and which we are using here, the system, you can see that is the two-probe system, and this one is basically the light source, and we have the optical fiber. Through the optical fiber, the light is incident on the probing station, and you can see there is a solar cell already given, and we have the two probe contact systems, and that is, and also there is a vacuum system such that the cell should be properly mounted on the probing station. And here you can see that the intensity of the light which we are using here, that is F plus 1.5, and which is equivalent to 100 watt per centimeter square. And this is basically the IV measurement system, and associated with this we have the interfacing, that is a laptop, the computer. Here you can see the scale, it is given current versus voltage, and we will now give the cursor, you can see the cursor, and here when we hit this, then we can do the measurement. Now you can see the measurement is given, and the values are also, you can see, I first gone through the values which is given here. You can see that the test, and after that the ISC. This ISC is the short circuit current, that is one of the solar parameters. In milliampere it is 157. Then the open circuit voltage VOC, that is 0.69, and then we have the Pmax. The Pmax is the maximum power getting obtained from here, that is 45. Then you have the Imax, that is maximum current density, and Vmax is the maximum voltage. And lastly, which is very important for us for any solar parameters, that is efficiency. How much we are getting? 22.6. I just want to say to the person, please focus the efficiency part more clearly, so that the people can visualize that 22.6%, and the fill factor is 41%, right? So what is from the graph, how we can see? That is, we know the solar cell is working due to the minority charge carriers present, as I told. Here you can see that there is the blue line is basically showing the fill factor, and the point, the red point where it is touching, this point is the Pmax. So that means the maximum power, and this point is basically corresponds to the VOC, open circuit voltage. Similarly, these points is show the ISC or JSC, the short circuit current density. So these are the points which you can see from any books, textbooks, and also my presentation. So now it is clear, I think, that how we can measure the solar cell for the solar cell measurements, right? Now again, another thing we want to see, that during the what we observe for under illumination. Now when in the dark condition, that means no illuminations are given. You can see this is in the dark phase we have seen. And if we come to the measurement side, if I will do the IV measurement, and we can see that the IV measurement, it will show just like a, yes, this is just like a diode characteristics. You can see this is just like a diode characteristics, and there is no part present in the fourth quadrant, right? Fourth quadrant, there is no part present here. So which signifies that there is no minority charge carrier generations occur due to absence of illumination. So from there we can continue, because this is just like a simple diode characteristics. So we can understand that without the light, the solar cell is behaving just like a diode.